Hello. Yeah. Hmm. Yeah. So how is it? Right? Okay. So wait for something more. It's coming up. Okay. 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 Now, do you want any videos? Okay. So I'll be making on acid bases and salt. Okay. 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 Group two elements starting with beryllium, magnesium, calcium, strontium, barium, and radium. So these are alkali metals. These are alkaline earths. Here we have 30 elements which are known as transition metals. They are all metals. These are post-transition metals in green. Post-transition metals. These are non-metals. Carbon, nitrogen, oxygen, fluorine, chlorine, sulfur, phosphorus, selenium, bromine, and iodine. These are noble gases. We don't know much about the properties of these elements starting with 109 ending on 118. We don't know. These are metals with unknown properties. The reason is that we don't have bulk of them to study. We have only been able to create a few atoms, 10 to 15 in number. This series of lanthanides, this is called lanthanide because it starts here. It should have been here between 57 to 72, but there is no place, as including these over here will disturb the symmetry of this periodic table. Right now, everything ends on a noble gas here, but including these 14 besides lanthanum, in between lanthanum and hafnium, and this 90 to 103 besides actinium would have created difficulty, and these two periods would have gone far out and disturbed the symmetry of this periodic table. So we are not able to adjust these. They all should come here. All of these should come here, but that is not to be. So they have been placed outside the body of the main periodic table. And these are the two disadvantages which we'll be seeing in written. Hydrogen, no place, no proper place, sorry, no proper place, can be in group 1, can also be included in group 17. 14 lanthanides and 14 actinides also don't get a place in the main body of the periodic table. And hence, even after all things have been seen, everything has been arranged to perfection, these two things remain unsolved. Relation between elements in the periodic table. Elements in the group have same valence shell electronic configuration. They possess similar chemical properties. The first element of a group is special. It has some special features. Lithium has properties similar to magnesium of group 2 rather than its own group members, like sodium, potassium, rubidium, cesium. Beryllium has properties similar to aluminium of group 13 rather than its own members, that is magnesium, calcium, strontium, and barium. Boron in group 13 resembles the properties of silicon of group 14. These three pairs are examples of diagonal relationships. They are also known as bridge elements. So what are bridge elements? Lithium, magnesium, beryllium, aluminium, boron, and silica. Three pairs. Elements at the head of a group are more likely to be non-metallic, but as we go down the group, the metallic nature increases. As we go down in a group, the metallic nature increases. So we are likely to find metals or elements with more metallic properties or proper metals at the bottom of a group. The relation between valence electrons and valency of elements. So here we have number of valence electrons, and here the valency if this is the number of valence electrons. So we have valence electron 1, valency is 1, valence electron 2, valency is 2, valence electron 3, valency is 3, valence electrons 4, valency is 4, but when valence electrons become 5, the valency reduces to 3. Valence electron 6, valency reduces to 2. Valence electron 7, valency reduces to 1. And when valence electrons are 8, valency is 0, as is the case with zero group elements or group 18 elements or noble gases. They have zero valencies. Merits and demerits of the modern periodic table. The modern periodic table has merits as well as demerits. Demerits I have already enumerated, that hydrogen still finds no fixed place in the periodic table. Lanthanides and actinides do not find a place in the main body of the periodic table. But there are merits. The merits are, instead of atomic weight being used earlier, this periodic table, the modern periodic table, uses atomic number as the fundamental property of an element. Position of an element is related to its electronic configuration, and that's why the outer shell, the outermost shell electronic configurations of a group is same for all group members, and that's why they form families. It is much easier to remember and use. Regular changes in properties of elements as one goes from left to right in a period and from top to bottom in a group. So as I already said in the previous slide or the slide previous to that, that it is more likely, we are more likely to find a non-metal at the top of the group, but as we go down, the non-metallic nature goes on decreasing, and finally we find metals at the bottom of the group. So there are regular changes in the properties of elements as one goes from left to right in a period and from top to bottom in a group. Now when we move from left to right in a period, on the left hand side we have metals, and as we go inside we have transition metals, then we have post-transition metals, and we have some semi-metals followed by non-metals, and the period ends with a noble gas. Valency of metals and non-metals. Metals have 1, 2, or 3 valence electrons. Must be noted very carefully. 1, 2, or 3 valence electrons. 1, 2, or 3 valence electrons, hence showing valency of 1, 2, and 3, as was explained in the valence electrons and its comparison with valency. Non-metals have 4, 5, 6, 7 valence electrons, hence showing the valency of 4, 3, 2 and 1 respectively. Noble gases having 2 electrons, as in helium, duplet, and 8 valence electrons, octet, and this one duplet, hence showing a valency of 0. They do not tend to combine with other elements. Metals do not bond with metals. They combine with reactive nonmetals by donating their valence electrons, forming what is called ionic bond or electrovalent bond. Nonmetals, on the other hand, combine with other nonmetals and bond with themselves by sharing electrons, as is the case with HCl, two different metals or two different elements, two different elements bonding with each other by sharing electrons. Oxygen, two same atoms bonding with each other. Nitrogen, two same atoms bonding with each other. And a ring of 8 atoms of sulfur bonded to each other, etc. There are many other examples, but these examples have been taken to, to, to explain the case. Variation of periodic properties in the table, that is the periodic table. So when we are saying a periodic table, what we are actually saying? We say that the atomic size or atomic volume increases in a group from top to bottom and decreases in a period from left to right. Always we go in a period from left to right and in a group from top to bottom. Metallic nature increases in a group from top to bottom and decreases in a period from left to right. Electronegativity, which is the power of an atom bonded to another atom covalently to attract the shared pair of electrons towards itself, decreases in a group from top to bottom and increases in a period from left to right. Electron affinity, energy given out when an external electron is inserted into a neutral gaseous atom, decreases in a group from top to bottom but increases in a period from left to right. Ionization energy, that is the energy required to remove one electron from the outermost shell or the valence shell of an element, of an atom, decreases in a group from top to bottom and increases in a period from left to right.